Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 16 physics series, where I am trying to help you achieve your dream of getting 60 marks in your upcoming 2025 KCET exam. And if you are one of the aspirant that you are preparing for KCET exam, then you should not miss any single video that I am doing in this channel, and it is absolutely free. Also, to get the class note, to get all the updates, also weekend KPL program, that is every Sunday we are doing mock test absolutely free of cost. For that you have to join our WhatsApp group. The link is given in the description. Every Sunday morning we are publishing the question papers for all the subjects, physics, chemistry and mathematics, that is for all the engineering subjects. So you have to join our WhatsApp group. The link is given in the description. And also don't forget to follow us in our WhatsApp group, so that you don't get any don't miss out on any of the notification. Now let's start with today's topic. We are going to discuss the chapter motion in a plane, complete chapter, only for important concepts for KCET. We are not going to discuss the entire chapter. There are many concepts that is not so important for KCET, so we are only focusing for KCET. So we will only discuss the important concepts which are very relevant for KCET. So let's look into the list of contents. We will start with the first thing, scalars and vectors. Then we will discuss specifically about vectors. A lot of things are there in the in this chapter. Next we will discuss addition of vectors, that is also important. Then we will see projectile motion, another very important questions. Every year almost one question comes from projectile motion, and sometimes question comes from vectors as well. So both are very important. Projectile motion is most important out of all the concepts. And then we will discuss about uniform circular motion. Based on that concept also sometime question comes from this chapter. So we will only focus on the areas where KCET questions are coming in the previous year exams. Okay, so let's start with the concepts or scalars and vectors. Scalar is a quantity with magnitude only. Obviously it's specified completely by a single number along with the proper unit. Examples are distance between 2 points. Very important is the examples. To remember the examples, because questions are coming based on the examples. So they will give you distance between 2 points or total distance traveled. Is it a vector quantity or scalar quantity? So you have to identify. Okay, based on, we will see one question. Then we will discuss mass of an object, the temperature of a body, and time, which is a certain event happened. So time is also a scalar quantity. Time is not a vector quantity. Now tell me one quantity which has some direction but not a vector quantity. I explained that in second PU chapter when that chapter was being taught. So now it's time for you to mention that in the comment below. Okay, now the rule for combining scalars are rules for ordinary algebra, that is 2 plus 2 is 4, that is ordinary algebra. Scalars can be added, subtracted, multiplied and divided just as an ordinary number. Okay, that's it. Now let's look into what is a vector quantity. A vector quantity is a quantity that has both magnitude and direction and obeys the triangle law of addition, or equivalently the parallelogram law of addition. So basically it is a quantity which has a direction and a magnitude as well. Also you cannot simply add them using normal algebra. You have to use the triangle law of or parallelogram law to add them. Okay, now let's see one question. Which of the following is not a vector quantity? Very simple question, that they have given you 4 quantities and they asked you which of them is not a vector quantity. So this is very important. Okay, some students generally get confused. Not means you have to check it in terms of negative options. Okay, so momentum is a vector quantity. We know that momentum has a direction, so it's a vector quantity. Weight, gravitational weight, that is being pulled towards the center of the earth, so weight is also a vector quantity. Potential energy, is it a vector quantity? Energy is the amount to do work. Work is a scalar quantity, so potential energy is a scalar quantity. And nuclear spin, any spin associated when the object is spinning in an orbit. Okay, there is a direction associated with. Some people might think that spin is a scalar quantity. No, spin is a vector quantity. So only correct answer is this, potential energy, it's a scalar quantity. Very simple question. If you know that answer, you can answer it. Okay, now let's move on to the concept of vectors. Very important thing. Okay, resolution of vector. So first we will start with resolution of vector, how to resolve a vector. So suppose we have one vector like this. Okay, one vector, any vector is there given like this. Suppose the vector is A. Okay, now we want to resolve this vector. What is the meaning of resolve? Resolving of a vector means we want to divide it into components, mainly two components where the axes are perpendicular. Most generally we assume the axes are along x-axis and along y-axis. Okay, most commonly these two axes are used, but remember that these are the not only two axes, any two perpendicular axes can be chosen. Okay, so any two perpendicular axes can be chosen. Okay, but generally we take x-axis and y-axis, they are standard axis. Okay, but any other two axes can also be chosen as long as they are perpendicular. Okay, now we are not going to discuss the general case here, that is for a conceptual part, but for now we will only focus on x and y axis. And if the angle makes with an axis is theta, okay, then this component of the vector is called adjacent component, and it is represented by magnitude of A cos theta. Okay, this is, you can do it using geometry. I am not doing that, mathematical part I am avoiding here. Okay, so this is A cos theta. This is adjacent component. This should be etched in your head, written in your head, that always the component which is adjacent to the angle theta will be cos component. Okay, and non-adjacent component, that is this component. Okay, this is A cos theta means up to this point. Okay, this is the resolution, this is the component. Okay, this part, if you take a point and draw a perpendicular, that is called a component, right? And this, the non-adjacent component will be modulus of A sin theta. Okay, you have studied that in your first PU. Okay, if you have not studied, then you should study now, so that you don't get confused. Okay, so this is the two components, very important. This is called resolution of vector. Resolution of vector nothing but resolving one vector into multiple components. Okay, so this has its application, may not directly be related to this chapter only. Questions are coming from other chapters where you have to do resolution. Okay, so especially say for example motion, laws of motion, and then system of particles, there is a problem where you have to do some resolution. Okay, so resolution is very important, where you are resolving one thing into multiple components, so x component and y component. Okay, now sometimes if you are writing in terms of x component, this is also called ax and this is also called ay. Okay, these are the components. Okay, now let's move on to the next part, dot and cross product. So what is the meaning of dot product? You have two vector quantities. Two vector quantities can be multiplied in two different ways. Okay, vector multiplication also we call it. So vector multiplication, how do we do it? So there are two ways. Either you do a dot product, it is also called a scalar product. When you multiply two vectors and the result is a scalar quantity, that is called a dot product. And when you multiply two vectors and the result is a vector quantity, that is called a cross product. Okay, example of dot product is the work done. Okay, where you are multiplying force, which is a vector quantity, and displacement, that is also vector quantity, but the resultant work is a scalar quantity. Example of cross product is torque. Okay, distance times force. There you are doing the same thing, but it is a vector quantity, right? Now let's move on. The application part, perpendicular vectors. If two vectors are perpendicular, suppose I have a vector here like say A, and I have a vector here, say vector B. Okay, and if they are perpendicular to each other, then we can write that vector A dot vector B equals to 0. If two vectors are perpendicular, then their dot product is 0. Now before going into any further, we need to know one more thing, how to represent a vector in 3 dimension. Okay, to represent a vector in 3 dimension, generally a vector is written like this: ax I cap, ay j cap plus az k cap. Sometimes one of these components will be 0, so that component will not be shown, but this is the representation of three vectors in three dimension. I cap, j cap, k cap are the unit vectors along x axis, y axis and z axis. So if you remember, in the resolution part I have done only two dimensional resolution. You can do such resolution in three dimensional as well. Okay, so that components of ax, ay, I said ax, ay, so those are the components of vector A, right? So you can write in terms of x cap, I cap, j cap. That is called the coordinate representation of a vector. Now things that you need to remember, that suppose A is this and B vector is equals to bx I cap plus by j cap plus bz k cap. Now dot product is easy. Okay, when you are doing dot product, there will be product only between similar terms, right? So here you can write that ax bx. Okay, I cap, only product between I cap will happen, so it will be ax bx plus ay by plus az bz. Okay, this is how you do the dot product. This will be equals to 0. Okay, if two vectors are perpendicular, then this dot product will be 0. Normally it has not, it need not to be a 0 value. Only when they are perpendicular, they are 0. Okay, now next is when the vectors are parallel. In case of parallel, the cross product is 0. If two vectors are parallel, then their cross product will be 0. Now cross product, to find a cross product, what you have to do? You have to do the determinant. You have to find the determinant of this. The way you find the determinant, whatever way you are comfortable with, there are two different strategies people use. Whatever strategy you are comfortable with, you can find using that method. Okay, okay, and in some cases, suppose only I cap, j cap is given, or only a small amount of is given. In that case, you also need to know the cyclic rule I cap, j cap, k cap. Okay, so if you are doing cross product of two similar vectors, in this case, if you are doing dot product of two similar vectors, that is only 1. Otherwise, all the other products, for example, I dot j is 0. Okay, I dot k is 0. Similarly, j dot I is 0, j dot k is 0, k dot I is 0, k dot j is 0. Okay, but I dot I is 1, j dot j is 1, k dot k is 1. Okay, but in case of cross product, it is opposite. I cross I equals to 0, j cross j equals to 0, and k cross k equals to 0. So when you are doing cross product between similar vectors, same unit vectors, they are 0. But when you are doing, say, I cross j, if you are doing I cross j, the result will be k cap. Okay, similarly, if you are doing j cross k, then the result will be I cap, and if you are doing k cross I, then the result will be j cap. So this is the cyclic rule. If in case, suppose the order matters here, suppose you are going in the opposite way. Okay, so you are doing j cross I. If you are going opposite direction of the arrow, okay, then it will be minus k cap. You have to be careful about that. In case you are doing I cross k, then that will be minus j cap. Okay, so if you are moving in this direction, okay, cyclic order, then it will be positive. If you are doing cross product in the opposite direction, then it will be minus. Okay, that is the important thing to remember about this. Now most important thing is, if you are doing parallel vectors, then you have to find the cross product and equate it to 0 to find some values. Okay, sometimes they will say that a vector and b vector are perpendicular. What is the value of this constant? What is the value of the angle, or etc. like that? They will might give you two vectors and they say what is the angle. So in that case, if you see the dot product is 0, then you can directly say the angle is 90 degree. This type of problems are very, very common. Okay. Now another important part is addition of vectors. Suppose we have two vectors, vector A and vector B. Okay. vector A is in this direction, vector B is in this direction. So as you have learned in the definition, in two ways you can add them. Either you can add them using law of triangle, or you can add them using law of parallelogram, but that mathematical part, that geometrical part, I am not going into the detail. The main thing that you need to remember, the resultant value of these two vectors is given by a square plus b square plus 2ab cos theta. Okay, direction is also not important for KCET. Only thing is the magnitude is important. Sometimes you may need to use this formula to find the magnitude. Direction is not important. Okay, so this is the basic part that you need to remember, that when you are adding two vectors, A and B are the respective magnitudes. Okay, now suppose I have a vector, say A vector equals to AX I cap plus AY j cap plus AZ k cap, then magnitude of the vector is basically square root of AX square plus AY square plus AZ square. Okay, this is very simple and easy to remember. Okay, this is the thing that you need to remember from this part. Okay, now let's move on to another important concept of projectile motion. So projectile motion is when you throw one object and it moves under the influence of gravity. So only external force that acts on this object is gravity. Okay, now there may be some air resistance present, it does not matter. So gravity should be predominant, and if the object is moving under the action of gravity, then it is called a projectile motion. Okay, even if you throw it directly upward, that is also a projectile motion. Okay, and if you throw it at an angle, that is also a projectile motion. Projectile motion, there are a lot of examples. For example, rocket launcher, even if you are shooting a gun. Okay, the shooters, if you have seen the Olympic, recently concluded Olympic, Paris Olympic, where our shooters won bronze, that is also influenced by projectile motion. That's why it is very difficult to target, especially for archers. Okay, when the archers are shooting, they have to take care of the gravity, they have to take care of the distance, they have to take care of the wind blowing. So there are all lot of things are there. So that's why this is very complex, right? Now angle with which it is projected, that is, this is the initial vector, velocity vector. Okay, angle at which it is projected, say theta, this is called angle of projection. I am not going to use theta naught, v naught. Okay, if you want, you can use u, you can use v naught, but I will use normal. Okay, this is angle of projection. Okay, now this trajectory which is followed by a projectile is called a parabola. This is a part of parabola. Okay, the parabola that you learned in the math is almost similar, but it is rotated and it's like this. But for projectile motion, it is a two-dimensional parabola and it is like this, so that's why it is also a parabola. I hope you remember the derivation, that was very important for your PU exam. So if you don't remember, I will remind you that as well. So now few things that you need to remember about projectile motions. What are those things? Time of flight. Okay, time of flight, total time of flight. So when you projected the projectile, okay, it takes some time to reach from the starting point to ending point. The total time is called time of flight. Okay, the maximum height is the maximum height attained by the projectile. So this is maximum height. You have to remember these values. Okay, for KCET is particularly these two are very, very important. Okay, I have not seen a single question based on time of flight, but this is also important concept. Sometimes maybe they will ask you one question based on time of flight this year. So that's why I included it, because in JEE and NEET this is also very important, time of flight. So in case they slightly change the question, concept of projectile motion is very important, because almost every year you see one question from this. So that's why I have also included the time of flight part. Okay, 2 v naught sine theta by 2. In case of maximum height, it is v naught sine theta by sine theta square by 2g. So v or v naught, whatever you sign convention you are using, the range is given by v square sine 2 theta by g. So if you remember, in both cases there is a square of v. Okay, you can write this as v naught square sine square theta by 2g. Okay, and how do you remember this? So in case of height, both v and sine both are squared, okay, and in the denominator there is a 2g. Okay, in case of range only v is squared, okay, that 2 was there in the denominator, now shifted to sine, and sine is no longer squared. Okay, that's how you can remember it. Okay, that's how I sometimes try to remember it. Okay, the way you are comfortable with, that is fine. If you remember v square by g, sine square theta by 2 in case of height, and sine 2 theta for range, that is also fine. Okay, so whatever way you are comfortable. Now range is maximum when theta is 45 degrees. Sometimes they will ask you the maximum range. Okay, for maximum range this is the value. So maximum range means when angle is 45 degree, angle of projection is 45 degree, that is called the maximum range. You should remember that. You have derived it, I hope you remember that, but otherwise only the value is important. Okay, now let's see the equation of projectile. That is also important. Equation of project, 1 year during all the KCET exam, only 1 year the question came based on this equation. So you have to remember that tan theta x, okay, minus g by v naught cos, this is not v naught cos theta square x square. Okay, so this is the formula for equation of projectile. I hope you remember this equation. If you not, then you have to remember this equation. Okay, sometimes in NEET exam also this question comes based on this equation. Okay, so this is the formula for equation of projectile. Okay, now let's see one problem. A particle is projected with a velocity v so that it is its horizontal range twice the greatest height attained by the maximum height. Okay, so maximum greatest height attained by the horizontal ranges. So let's see the question. This is a little complicated question, came in KCET. So what is the particle projected with the velocity so that its horizontal range? So what is the horizontal range formula? Horizontal range formula is v square sine square theta, both are square, so there will be a 2g in the numerator. Okay, and range is v square sine 2 theta by g. Okay, 2 already occupied upstairs, so there will be no g in the downstairs. Now they have said that maximum height attained is twice the greatest height attained. So twice h equals to the range, that is given. Okay, so 2h equals to r. Now put the values of h. H is v square sine square theta by 2g, okay, equals to v square sine 2 theta by g. Okay, now let's do the mathematics. These two cancels, v square cancels, g cancels. So you can see that sine square theta equals to sine 2 theta. Okay, now what is the range? Range is equals to v square sine 2 theta by g. We have to find this value. So if we can find the value of sine 2 theta, then we can calculate the range, right? Now sine 2 theta equals to sine square theta. So what we have to do? We have to do sine square theta equals to, what is sine 2 theta? Sine 2 theta is nothing but sine 2 sine theta cos theta. Okay, or one of the sine will be cancelled. If you see, one of the sine will be cancelled. So sine theta equals to 2 cos theta. Okay, now we have to find the value of sine 2 theta. So from this equation, how can you find the value of sine 2 theta? So what we will do, we will take this cos theta on this side, so we can write tan theta equals to 2. So if we can write tan theta, we can write sine theta as well, right? Tan theta, remember that tan theta is perpendicular by base, and sine theta is perpendicular by hypotenuse, whereas hypotenuse equals to p square plus b square. Okay, these things you have to remember. Now tan theta can be written as 2 by 1, right? It can be written as 2 by 1. So what we will do, sin theta is nothing but 2 divided by square root of 2 square plus 1 square. Okay, or sin theta equals to 2 by root 5. Okay, sin theta is 2 by root 5. Now one more thing, if you see, we are trying to find sin 2 theta, right? In this equation you see sin 2 theta is nothing but sin square theta. So if I square this term, I will get sin 2 theta, right? So sin 2 theta is nothing but sin square theta. Why? Because in this equation we have achieved that only for this problem. This is not a general statement. So 2 by root 5 whole square, that is 4 by 5. So sin 2 theta we have calculated. Now put the value here. So v square by g times 4 by 5. So it will be 4v square by 5g. Okay. So let's see the options. 4v square by 5g. So option D is correct. Okay. Problem is little messy. It required a lot of space, but I hope you enjoyed this problem. This is a very enjoyable problem so far that I have seen. Okay, now let's move on to the last concept of uniform circular motion. In uniform circular motion, from this chapter only one important concept is centripetal acceleration. What is centripetal acceleration? When an object is rotating in a circle, okay, the object experiences an acceleration towards the center, okay, and the velocity is along this direction. Okay, this is only important concept for KCET, not tangential component, vertical component. There are a lot of things that is there in JEE, but for KCET is simple. So tangential velocity is along the tangent and acceleration is along the radius. Okay, so you can see that the angle between velocity and acceleration is always 90 degree. Okay, no matter what, if it is a uniform circular motion, the angle between velocity and acceleration will always be 90 degrees. There is a centripetal force, but that part we will discuss in our next chapter, because force we have not yet discussed. So anything related to centripetal force that will be discussed in next chapter, uniform laws of motion. Now let's see one question that came in KCET 2023. Very simple question. The particle is in uniform circular motion. Related to one complete revolution of the particle, which among the statements is incorrect? So this is a very simple question. So they have said that a particle completed one complete motion in a uniform circular motion. Okay. Now which of the following is incorrect? Again, so simple question, they just tried to make it little complicated if you are not reading it properly. So that's why I always suggest read the question paper completely. The answer is hidden within the question. Okay. So incorrect. Which statement is incorrect? Displacement of the particle is 0. Displacement is 0. Yes, correct. Particle starts here, particle ends here. So displacement will be 0. Total distance traveled will not be 0. Average speed of the particle is 0. Average speed of the particle is not 0. So average speed of the particle is not 0 because total distance traveled is not 0. So total distance traveled divided by total time is average speed, which is not 0. So this is the wrong statement. This is the wrong statement, means this should be our answer. Let's see other options as well. Average velocity of the particle is 0. Yes, average velocity of the particle is 0. Average acceleration of the particle is 0. Average acceleration of the particle is also 0 because it's a vector quantity, and if displacement is 0, total displacement is 0. Okay, then velocity will be 0, average velocity will be 0, average acceleration will also be 0. Okay, but average speed will not be 0 because total distance traveled, which is different than displacement. Okay, we discussed about that briefly in our previous lecture, previous chapter discussion, right? There we have discussed about it. So you should remember that total distance traveled is not 0, so average speed is not 0. But displacement is 0, that's why average speed is 0, average acceleration is 0. Okay, So I hope you enjoyed this session. It's a very small brief session where we have completed the entire chapter within 30 minutes. Okay, and entire series we have already completed the second few chapters. We will do revision of the chapters obviously, but the entire lecture series where I have discussed all the concepts in detail, in depth. Okay, if you want to see them, there is a playlist available for that. Any time of your between your study you can find some time and you want to study some physics in-depth concepts, you can go there and you can study that. This is specifically focused on KCET. So if you are preparing for KCET 2025 any point of the year, then you can go there and you can start studying from that lecture series. Okay, so I will be back with more such videos, but before that, before I go, you should remember that there will be a KPL in coming Sunday. Okay, so if you want to participate in KPL, the only thing that you have to do, you have to go to our WhatsApp channel, then click on the follow icon, so whenever we are posting an update, you are getting a notification, and whenever we are posting the KPL question papers, you can download it, you can solve it, and we will be providing the solution also. So don't worry, we are not leaving your hand, and everything is absolutely free of cost. So don't go anywhere, follow our channel, share with your friends, and subscribe to our channel. I will be back with previous year questions from this chapter tomorrow. Till then, bye bye.